Hello everybody, I am Sudharani, Assistant Professor working in Guru Nanak Institute of Technology in Physics Department. Today we will study the IV characteristics of LED. IV means current voltage characteristics. We will allow current to pass through the LED and we will see how the voltage changes according to it. I think you must be knowing the abbreviation of LED. LED stands for light emitting diode. Light emitting diode. By the name it is quite obvious that it emits light. This is just a diode which emits light. Okay. Then what is the difference between ordinary diode and this diode? Ordinary diode will not emit light. This diode emits light. Why it emits light? That is due to the band gap. The normal semiconductors we get, like natural semiconductors like silicon and germanium, they have the band gaps of silicon has band gap of around 1.1 electron volts and germanium has band gap of around 0.7 electron volts. And because of this band gap, they are unable to give out light. Suppose you take energy equation is equal to Hc by lambda. Suppose you take lambda here, lambda is equal to Hc by Eg. You can write the equation like this, where lambda is a wavelength of light that is emitted, H is a Planck's constant, C is the velocity of light, E is the energy gap. Suppose you take this energy gap and calculate the wavelength for silicon and germanium. For diodes which are made up of silicon and germanium, the wavelengths that you are getting are such that they are not in the visible range. They emit radiation, but we are not able to see that radiation. That is why we are unable to identify light in that. Whereas for LEDs, we will not use germanium and silicon, we will use materials like gallium arsenide, which is a composite semiconductor. This is a compound semiconductor which is made by combining, forming an alloy of gallium arsenide or materials like gallium phosphide, indium arsenide, etc. Now we have a wide variety of materials which are available for forming these semiconductor diodes. In these materials, the specialty of these materials is that the band gap is in the range 1.4, more than 1.4, like it ranges from 1.44 to 2.5 electron volts, so that if you substitute in this equation, you will get the wavelength in the visible range. Now we have a wide variety of LEDs which are available in different colors, like we have blue, green, orange. In fact, all the Diwali lights that are they are nothing but LEDs only. So they have variety of uses. There is no field where you don't use this LED. The aim of this experiment is to study the current and voltage characteristics and the threshold voltage of LED, of the given LED. And the apparatus that is required is, you have a kit which is LED characteristics board, and second one is a connecting wires, very simple apparatus. And the theory, let us see the theory of this experiment. And this is just a diode, this is the LED, and here we have P side and we have N side. This is nothing but a normal diode, and to this side you connect a battery, and this battery is a variable battery. You connect a variable battery, this arrow mark here indicates that it is a variable one, and this is connected to N type. And here we have the potential barrier. Between P and N region there is a potential barrier, and majority carriers in P side are holes and majority carriers in N side are electrons. And now you connect it in such a way that this is forward biased. You apply a forward bias to this diode, that means P side is connected to positive of the battery, N side is connected to the negative of the battery. When you apply a voltage which is more than the potential barrier, you have the potential barrier here. If you apply a voltage more than potential barrier, then what will happen? the holes are repelled by this positive charge of the battery, they rush towards the potential barrier, they rush to the middle of the region. Similarly, the electrons here are repelled by the negative terminal of this battery and they will rush towards the depletion region. And here they undergo recombination. Each time one electron meets a hole, they annihilate and they give out the energy, and this energy is given out as radiation, which we see as a particular color. So, we can adjust this band gap as you can see in this formula. You can adjust this band gap to get whatever wavelength we want. Suppose I want red light, I will adjust the wavelength accordingly so that I get that particular wavelength of around 6000. Suppose I want green light or blue light or whatever color I want. Simply by adjusting this energy gap, I can get variety of colors that I want by this LED. And in this experiment today, we are just going to pass current in this and measure the corresponding voltage across the terminals of this diode. And here is a table